So hi, I'm Nikolaos Tavoularis. I will speak about. Hi. I'm Nikolaos Tavoularis, and I will present you the virtual machine tools, which are some tools that helps OpenVMS when it runs in a virtualized environment like KVM or ESXi. And VM tools will be available in version 9.2.4. This is the agenda. I will start with a small introduction and an overview of the project. We will speak about timekeeping, graceful power operations, a detached process that runs in the background, and finally we will have a small demo. So, first let me introduce myself and the Greek branch. I am one of the team lead developers in the Greek branch. I started working in OpenVMS about a year and a half ago. And I have a background in firmware development and embedded systems. And the Greek branch also started about a year and a half ago. We have this photo of us, but it's a kind of an old photo. We have some new pictures here. The photo was taken during the visit of Paul Jacob in Greece. And we are 11 people now. We are a lot of young engineers, really excited to work for OpenVMS. And VM Tools is our first project. So let's go to VM Tools. It has two important features. The timekeeping will synchronize the OpenVMS clock with the host clock, and graceful power operations that allow us to send commands like suspend, shut down, and reboot from the hypervisor to the OpenVMS system. And we achieve that by some new digital qualifiers like the set time/host and the detached process that runs from the background. So I will start with timekeeping. First of all, in every virtual machine, regardless the operating system, we have a clock tree. This because we do not have an actual clock. We are in a virtualized environment and we have small errors, and that errors are accumulated. So we need a method to adjust the clock of our virtual machine, and we have to do it more often than a physical machine. And of course, there are the traditional methods like the NTP and the DTSS. But sometimes it is better to synchronize with the host because it is faster, and in case of time, faster means also more accurate. It requires no network access and less resources. So we can synchronize also more often. And before we continue, let's see how OpenVMS represents time. OpenVMS represents time in 100 nanoseconds since 17th of November 1858. This is known as the modifying Julian date, and it is used a lot by the astronomers and, of course, the OpenVMS system. Now, internally, OpenVMS has a clock that it updates it every 1 millisecond. So we have 1 millisecond precision. Now, let's say that we have a clock source like an NTP, or in our case, the host. And we receive a timestamp and we want to update the OpenVMS clock. There are two ways to do so. They are stepping and they are slewing. So by stepping, we immediately adjust the OpenVMS clock to the correct timestamp. And we instantly have the correct time. But there's a disadvantage of this. We have clock jumps. And we may even jump backward in time if the OpenVMS system is ahead of the host. That's why we're using slewing. With slewing, we gradually adjust the OpenVMS time until it reaches the host clock. And finally, we have the auto methods that decides automatically between these two. Essentially, we have a threshold called the step threshold, and if the time difference by time difference, I mean the absolute value, is equal or above the step threshold, then we step. Otherwise, we slew. So slewing is better for small time differences. And these algorithms are not new to OpenVMS. They exist since DTSS. Now let's see how slewing works. So we have ticks in 1 millisecond. We have an interrupt in 1 millisecond, so interval. And every 1 millisecond, we update the clock, we increase the clock. And we increase the clock by the tick length. So if we have a tick length with a value of 1 millisecond, we increase the clock in every millisecond by 1 millisecond. And we have a steady clock. Now we can make our clock to go faster. So we can increase the tick length to add something more in this millisecond. We can add some nanoseconds. And we will have a clock that is going fast. And we can make even our clock to go slower by decreasing the tick length by a few nanoseconds. And there is another important variable here, the time adjust. So if we modify the tick length, time adjust tells us for how many ticks we will have this modified tick length. So essentially the algorithm is the following. We are in the interrupt and we increase the clock by the tick length. Then we decrease the time adjust. And when the time adjust reaches 0, we restore the tick length to its original value, which is 1 millisecond. And by choosing this variable correctly, we can gradually reach the host clock. Now, this is the main algorithm for clock synchronization. The algorithm is actually simple. The first thing we have to do is to retrieve the host time. And this is depending on the hypervisor. So in KVM, we have a combination of a shared memory and writing to some model-specific registers of the virtualized CPU. In ESXi, we use the VM call or VMM call instruction. But in every case, we retrieve the time in UTC, and that means that we are independent and unaware of the time zone of the host. Then we have to convert it to something that OpenVMS understands, which is the modifying Julian date. After that, we are our own TDF to convert it to our local time. And we have to decide between the two methods, the stepping and slewing. And finally, we update the time. In case of step, we adjust the clock directly. And in case of slewing, we change the tick length and time adjust. Now, how can we trigger a time update? We have some new qualifiers like the show time/host and the set time/host. With the show time/host, you can see the time of the host in our own time zone, and we can even see the time difference between our machine and the host machine with show time/host/diff. And the difference is the host minus the guest minus the OpenVMS system. So if we have a negative difference, that means that we are ahead of the host. And finally, we can set time with set time/host, which updates the OpenVMS clock immediately and set it to the host clock. So the default here is step, but we can add some values to change the adjustment method, like set time/host equals step, or equals slew, or equals auto. And still we need the privileges, the log IO and Oper as usual. Now another important aspect of timekeeping is how it handles the power operations. Generally, when we power on the machine, we immediately have the correct time. Because we do not have an RTC clock, this is virtualized by the clock of the host. That also means that if we have a clock jump while our system is offline, then if we power it on again, we will have a clock jump in the OpenVMS system as well. Another thing is that we have the pause resume mechanism in virtual machines. Of course, I do not advise you to pause the production server, but if you do so and you are running VM tools, you will have the correct time afterwards. In case of KVM, the time will be updated in the next second. In case of ESXi, you have to run the detach process in the background, and you will still have the correct time. And in every case, we update the time with step after a pause resume. Now let's see the graceful power operations. Graceful power operations allow us to send commands like suspend, shut down, and restart the guest operating system from our hypervisor. This is a screenshot from ESXi, or from VSP. So in case of ESXi, we need a message exchange mechanism. So the hypervisor will send us commands like power operations or time sync, or we will receive ping messages that we have to respond in order to tell the hypervisor that we are up and running and that we support these features. So in case of suspend here, after the resume, we will receive also a time sync message. We will update the time. That's the reason that we have to run the detach process in the background in order to have the pause resume clock update in case of ESXi. Now in KVM, we can still send the same commands, but KVM uses the existing ACPI commands. So we support this feature without the VM tools. We do not need them because we already support the ACPI. Now let's see how the detach process works. It handles timekeeping by updating the time periodically and the graceful power operations in case of ESXi. You can start it or stop it with the startup and stop scripts, and we can set the parameters that we need on the startup script. This is the location of the scripts. They are all located at the $6 manager directory. The startup script is called VMTools $daemon underscore startup.com. The stop script is VMTools $daemon underscore shutdown.com. And of course, we have a log file at the same directory with the name VMTools underscore daemon.log. So if you can add the startup script, set battery on the microphone. Okay, I will speak louder. Okay. Oh, okay, you can hear me now, I think. So you can add the startup script at your system startup, sysstartup script in order to automatically start it after boot. So this is the parameters that we have in the detach process. First of all, you can enable or disable timekeeping with the timekeeping enable parameter. Notice that if you would like to run timekeeping, you have to disable DTSS or NTP. And if you prefer NTP, then you should disable timekeeping here. You can also disable the power ops with the power ops enable command parameter. In case of KVM, power ops are disabled automatically, so you don't have to manually disable them. And the next parameters are for timekeeping. First of all, we have the precision. Precision tells us when the two clocks are synchronized. Yes.
Is that dynamic or read once at the detach process startup?
Once during startup, then you have to close the detach process and run it again.
Okay.
You don't need the reboot, however.
No, I understand.
So we have precision. Precision tells us if the two clocks, the host clock and the OpenVMS clocks are synchronized. Any time difference below precision are considered negligible. The default value is half a second. You can lower to 10 milliseconds to have better precision. And the maximum value is 5 minutes, but you should not set such great values. Then we have period. The touch process periodically updates the time. The default value is 1 minute. But if you run the touch process and you still have a clock drift, then you can make the period lower with a lower value of 10 seconds and the maximum of 7 days. Then we have step threshold. The default value is 5 minutes, and that means that if we have a time difference from 5 minutes or greater, we step. Otherwise, we slow. Now the minimum value here is 0. That means that we completely disable slew, but it's better to have some small slew value for better performance. And the maximum is 24 hours. And the next parameter is the adjustment rate. The adjustment rate tells us how fast we will reach the clock source, the host clock. The default value is 10%. That means that in every tick, we increase the tick length by 10% of each original value. Or we decrease it if we want to make our clock go slower. The default value is 10%, the minimum is 1%, and since it is a percentage, the maximum is 99%. So, also the slew is used also in DTSS. The default value in DTSS used to be 1%, it is 1%, but we decided to make it reach the host clock a bit faster, and the default value here is 10%, but feel free to change it to 1% if you prefer the previous behavior. Now, also all these parameters, when they regards time, it's in milliseconds. And also, these are the default values, and when you set the time with the set time / host command, you always use the default values here, but you can change them for the detached process. And finally, we have the logic level. The default value is 3. We have 4 logic levels, 0 for fatal, 1 for errors, 2 for warnings, 3 for success, and 4 for informational messages. So 3 means that we print all logs from 0 to 3. So this is a screenshot from the edit command that we edit the startup script to change the parameters. They are located at the top of the script after some initial comments. So now some best practices. You always have to synchronize your clock, either with DTSS or NTP or timekeeping. If you want to use timekeeping, please disable DTSS or NTP. And if you want to use NTP, please disable timekeeping. Now, if you want to use timekeeping, you have also to synchronize your host machine. And also, something I forgot to write here is that there is a bug in Linux kernel in versions previous to 6.7, so you will have more accurate time from version 6.7 and later. And also, you don't have to edit the parameters except if you have some special needs for your application or your system have some special or if your virtual machine and the host needs it. Now we will have a small demo to see how this runs. Actually,
yes. With KVM, where you do not have the detached process, how do you get the equivalent functionality of the shutdown? What shutdown, restart operations and stuff that you get with the SXI? Like, how can I tell a VMS system that's a guest under KVM, shutdowns are not allowed?
You want to disable the shutdown feature in KVM.
In KVM, I wanted to have the same function that I can have in ESXi where I can say, you're not allowed to shut down the VMS system.
You have to do it in the option of KVM because we use the ACPI commands. We support ACPI. I don't think that we can disable the ACPI commands.
I understand. You and I can talk about that. Have people asked you also for a finer granularity, like be able to say you could do a shutdown, but you cannot do a shutdown and a restart?
That's interesting. We never thought of it. No. We thought like we will support all of them, but you should not press the shutdown if
I can give you
you
examples.
don't.
This is good stuff. This is really good stuff.
Okay, thank you. Can we see a small demo and then you can ask me more questions? Connect. So here is the ESXi machine in vSphere. This is my machine that we will connect. In actions here, you can see power and shut down and restart OS, which are disabled because we do not run the detached process right now. So this is the, just give me a moment to. So this is the terminal for my machine. We can see the time, and we can see the time of the host, and we can see the time difference. And we are very close. So let's see what happens if we change that. First, we have to set the privileges.
Definitely, because I have a symbol to do exactly that set process command in my wedding.
Let's go about 5 minutes ahead. So time plus host plus diff show us a great time difference, and it is negative because we are ahead of the host. So now we can set the time. We have a message here that we use step because it's the default value. And we have a difference less than 1 millisecond or 1 millisecond. Now we can also use slew. Auto will decide slew in that case because we have a time difference less than 5 minutes, I think. Yes, slew synchronization. And now we can see the difference. And we still have a great difference, but it is decreasing. And eventually we will reach the host clock. So term. Now I will fix the time because we do not have to wait. You can use if you use the command again, it rewrites the previous slew parameters. And now we can start the detach process. First, let's see, edit. This is the location of the detach process. There are some initial comments, and here you can see the parameters. Feel free to change them, but keep the original version in case you want to go back. I will not change it right now, but I will start the detach process. And now that we can see that it is running, we can read the logs also. This error just tells us that the hypervisor does not support the preferred version of message exchange mechanism, so we have a fallback. This is not an important error. And here, you should see that we have these actions enabled. We can shut down, we can restart. Now we'll suspend the machine. It takes a while in ESXi. So now I will resume it. And we can see step synchronization with the host after the pause resume, so we have the correct time. And finally, I will shut down the VM gracefully. And you can see the VM is closed. Thank you. So, any questions?